Hello everyone, this is Aman Kumar. Welcome to today's class. In today's lecture, we are going to learn a very important concept from the chapter Arithmetic Progression, which is the proof of sum of n terms of an AP. Okay, so let's start our today's lecture. So before learning the proof, first we quickly revise what is an AP. So now look on the board. If I write a series like that, suppose this is my series 2, 5, 8, 11, 14, up to so on. So now look, if the difference between the consecutive terms of this series are equal, then we say that this series is in an AP. So what is the meaning of consecutive terms? So consecutive terms means this 2 and 5 are consecutive terms, 5 and 8 again they are consecutive terms, 8 and 11 are consecutive terms, 11 and 14 are consecutive terms. So consecutive terms means terms after each other another. Now the question is what? If the difference of these consecutive terms 2 and 5, 5 and 8, 8 and 11 and 11 and 14 are equal, then we say that this series is in an AP. Okay, so let's check it out. They are same or not. So first we see a difference of 5 and 2, which is what? 5 minus 2, that is 3. Now we said the difference of 8 and 5. Now difference of 8 and 5 is what? 8 minus 5, that is 3. Let's check it for 11 and 8. Then difference of 11 and 8 is equals to what? 11 minus 8, that is again 3. Now let's check it for last one, which is difference of 14 and 11 is what? 14 minus 11, that is again 3. Now see, I told that if the difference between consecutive terms are same, then the series is in an AP. Now see, the difference between the consecutive terms there are same. Then this series is an AP, that is arithmetic progression. And we denote this difference by a small d. This is known as common difference, which is denoted by a small d, and the first term of a series is called first term of an AP. First term of an AP, which is denoted by small a. Okay, understood? What is an AP? If the difference between consecutive terms of a series are same, then we say that the series is an AP, and the difference is denoted by a small d, which is common difference, and the first term of the series is denoted by small a. Okay, now let's move towards our proof of finding the sum of n terms of an AP. Now suppose we have an AP A, A plus D, A plus 2D, A plus 3D up to n number of terms, and we have to find the sum of the first n terms of this AP, which is A plus D, A plus 2D and A plus 3D up to n number of terms. So we have a formula for finding the sum of n terms, which is Sn is equals to n by 2 in bracket 2a plus n minus 1 into d, where n is equals to what? Number of terms. Okay, if I use this formula, then we easily find the sum of first n terms of this AP, and in this lecture we see the proof of this formula, how this formula is derived. Understood? So now let's move towards the proof. So for this, in first step I simply write the sum of this terms. So S is what? Sn means sum of n terms is what? A plus D, then again A plus 2D, then again A plus 3D up to n number of terms. I write the sum in simple way, and this is my equation first. Then in next step I write the same thing, but this time in reverse order. So in reverse order, Sn is what? This I take L. Okay, L is here last term. I don't write N, I write L, which is the last term. N is denoting number of terms, and L is the last term. So now Sn is what? L plus L minus D plus L minus 2D plus L minus 3D up to first term, and this is my equation number second. Now in third step I add these two equation. So third step is what? Add equation first and second. So after adding both the equation, what we have? Sn is 2Sn is equals to a plus L here, a plus D, L minus D. So a plus D plus L minus D, again a plus 2D, L minus 2D. So a plus 2D, L minus 2D. Now this is up to n. Okay, I don't write this due to space. So now dd is cancelled, 2d is cancelled. So what I left? 2Sn is a plus L, again here a plus L. Now from here again a plus L, and this is carry forward to n number of terms. So now look, a plus L, a plus L, a plus L up to n terms. Then I write 2Sn is equals to n times a plus L. Now this 2 goes this side, so this will become Sn is equals to n by 2 a plus L. So this is one formula for finding n number of terms, but our formula is Sn is equal to what? N by 2 a plus n minus 1 into d. This is our formula. We get Sn equal to n by 2 a plus L. Now in place of L we substitute one formula. L is what here? L is the last term. So in place of L I substitute the formula of nth term of an AP, which is what? Nth term of an AP is what? A plus n minus 1 into d. This is the formula of nth term. So I put this formula in place of n, L here. So in place of L, if I put this formula, this will become what? Sn equals to n upon 2. Now this is A plus, in place of L, I write this one. This is A plus n minus 1 into D. Due to space, I write in smaller thing. So now look, A plus A is 2A and n minus 1 into D. So A plus A is 2A and n minus 1 into D. So I simply write this one as n upon 2 and 2a plus n minus 1 into d. This is our required formula, and this is the proof of this formula, how to find the sum of n terms of an AP, which is n by 2, 2a plus n minus 1 into d, and here n is what? Number of terms. Okay, now let's see one example, then we end this lecture. Now look, suppose we have an AP where a is 3, okay, a is 3 and d is 2 and n is 5. Here a is first term, common difference d is 2 and number of terms is 5, and we have to find the sum of first 5 terms of this AP. We have to find this one, sum of first 5 terms of this AP. So how we find? We use the formula which is Sn is equals to n upon 2, 2a plus n minus 1 into d. So see here, S5, here n is 5. So 5 upon 2, 2a, 2a is given 3 plus n minus 1, which is 5 minus 1, and d is here 2. So now see, this is what? 5 by 2 and 2 3s are 6 plus 5 minus 1, 4 into 2, which is 8 here. Now S5 is what? 5 by 2 multiply 8 or 6 is 14. Now 14 is cancelled out by 2 by 7 times. So from here S5 is 7 5 the 35. So S5 is here 35. Okay, let's check this is right or not. So this is my AP where A is 3, D is 2 and N is 5. So how I write this AP? A is 3, D is 2. So AP is this what? A, then A plus D, A plus 2D, A plus 3D and A plus 4D. This is AP. So A is here 3, A plus D means 3 plus 2. A plus 2D, which means 3 plus 2D means 2 into 2, which is 4. Then A plus 3D. A is 3. Now 3D is what? 3. D is 2. So 3 to the 6. Okay. Now A plus 4D. A is here 3 plus 4D means D is 2, 4, and 4 to the 8. So our AP is 3, 3 to 6, 4 or 3, 7. This is 5, 7, and this is 9, and this is 11. So this is my AP. Now I have to find the sum of these 5 terms. So 3 plus 5, 8. 3 plus 5 is 8. 7 plus 9, 16 plus 11. Now do this one. 8 plus 6, 1, 7, 1, 1, 2. So 27. 27 or 8 is 35. So see, by using this formula we get 35, and the sum is also 35. Understood? That's all for today's lecture. If you found this video helpful, then practice some question by your own. Okay.